Hello students, I am Swarn from KV Muradabad. Today we will start a new chapter, Trigonometric Functions. In this chapter, we shall look into the introduction, angles, trigonometric functions of sum and difference of two angles, and trigonometric equations. Now, let us introduce ourselves to trigonometry. The word trigonometry is derived from the Greek words trigon and metron, and it means measuring the sides of a triangle. The subject was originally developed to solve geometric problems involving triangles. It was studied by sea captains for navigation, surveyor to map out the new lands, by engineers and others. Currently, it is used in many areas such as the science of seismology, designing electric circuits, describing the state of an atom, predicting the height of the tides in an ocean, analyzing a musical tone and many other areas. In earlier classes, we have studied the trigonometric ratios of acute angles as the ratio of the sides of a right angle triangle. We have also studied the trigonometric identities and application of trigonometric ratios in solving the problems related to height and distances. In this chapter, we will generalize the concept of trigonometric ratios to trigonometric functions and study about their properties. Thus, in general, there are two approaches to trigonometry. One approach centers around the study of triangles, which we have already studied in class 10. Other one is the unit circle approach, in which we use radian measure of an angle to define trigonometric functions of real numbers. It meets the requirements of calculus and modern mathematics. Now, what is an angle? Angle is a measure of rotation of a given ray about its initial point. The original ray is called the initial side, and final position of the ray after rotation is called the terminal side of an angle. The point of rotation is called the vertex. If the direction of rotation is anti-clockwise, the angle is said to be positive, and if the direction of rotation is clockwise, then the angle is negative. Look into the figure. Here, when the direction of rotation is anti-clockwise, the angle is taken as positive, and if the direction is clockwise, the angle is negative. Now, let us study about how to measure these angles. The measure of an angle is the amount of rotation made to get the terminal side from its initial side. There are several units for measuring angles. One unit of measuring angle is one complete rotation. Here you can see in the figure, one complete rotation is considered as 1 unit. Now, we shall discuss about the systems of measuring angles. Firstly, degree measure. In this system, an angle is measured in degrees, minutes and seconds. A complete rotation describes 360 degrees, that is 1 degree is equal to 1 upon 360th of a complete rotation. Therefore, one right angle is equal to 90 degrees. A degree is further subdivided as 1 degree is equal to 60 minutes and 1 minute is equal to 60 seconds. Second one is radian measure. In this system, an angle is measured in radians. A radian is an angle subtended at the center of a circle by an arc whose length is equal to the radius of the circle. Here in the figure, let AB be an arc of a circle with center O and of radius r, such that length of the arc AB is equal to r. Then angle AOB will be 1 radian. Now, let us see the relation between degree and radian. Since a circle subtends at the center an angle whose radian measure is 2 pi and its degree measure is 360 degrees, it follows that 2 pi radian is equal to 360 degrees. That means, pi radians is equal to 180 degrees. That implies 1 radian is equal to 180 degrees upon pi, which can be calculated as 57 degrees 16 minutes approximately. 1 degree is equal to pi upon 180 radians, that is equal to 0.01746 radian approximately. Look here, we have relation between degree measure and radian measure of some standard angles. In this table, we have degree and radian. Degree 30 degrees can be written as pi upon 6, 45 degrees can be expressed as pi upon 4, 60 degrees as pi upon 3, 90 degrees as pi by 2, 180 degrees as pi, 270 degrees as 3 pi upon 2 and 360 degrees as 2 pi. Thus, radian measure is pi upon 180 into degree measure and degree measure is 180 upon pi into radian measure. Here we have an important result. If in a circle of radius r, an arc of length r subtends an angle theta radian at the center, then we have theta is equal to L upon r or L is equal to r into theta. Now, having studied the relation between the degree and radian, let us solve some examples. Convert the following into radian measure 25 degrees. We know that 180 degrees is equal to how many radians? Pi radians. Therefore, 1 degree is equal to pi upon 180 radians. That is why 25 degrees will be 25 into pi upon 180 radians, which can be simplified as 5 upon 36 pi radians. One more example here, which is involving degrees and minutes. Minus 47 degrees 30 minutes can be written as minus 47 plus 30 upon 60 minutes, that is minus 47 and half seconds, which can be easily calculated and converted into radians as minus 19 upon 72 into pi radians. Let us take one more example involving degrees, minutes and seconds. 5 degrees, 37 minutes and 30 seconds can be easily solved as 5 degrees plus 37 plus 30 upon 60 minutes, which on simplification will give 5 degrees plus 75 upon 2 into 1 upon 60 degrees. That is 5 degrees plus 5 upon 8 degrees can be written as 45 upon 8 degrees. Now, converting into radians by multiplying with pi upon 180, we get pi upon 32 radians. Now, let us see one more example. Convert the following radian measure into degree measure using pi is equal to 22 upon 7, 11 upon 16. We know that pi radians is equal to 180 degrees. Therefore, 1 radian is equal to 180 upon pi. Therefore, 11 upon 16 radians is equal to 11 upon 16 into 180 upon pi. That can be simplified as 315 upon 8 degrees or 39 3 upon 8 degrees. 39 degrees plus 3 upon 8 into 60 minutes can be again expressed as 39 degrees plus 45 upon 2 minutes or 39 degrees 22 minutes and half of 60 seconds. which is again simplified to 39 degrees, 22 minutes and half of 60 seconds as 39 degrees, 22 minutes and 30 seconds. One more example, the minute hand of a watch is 1.5 centimeters long. How far does its tip move in 40 minutes? Use pi is equal to 3.14. In 60 minutes, the minute hand of a watch completes 1 revolution. Therefore, in 40 minutes, the minute hand turns through 2/3 of a revolution. Thus, theta is equal to 2 upon 3 into 360 degrees or 4 pi upon 3 radian. Hence, the required distance travelled is given by L is equal to r theta, an important relation, is equal to 1.5 into 4 pi upon 3 centimeters, which on simplification gives us 2 pi centimeters. We are using the value of pi as 3.14 as it is given in the question, and we can write it as 2 into 3.14 centimeters, that is equal to 6.28 centimeters. So, students, today we have introduced ourselves to trigonometry, angle, degree measure, circular measure and relation between degree and radian. We have solved examples also concerning degree measure and radian measure. So, students, in the next session we shall study about trigonometric functions. Thank you.